Hello everyone. The topic which we are going to learn today is rational number. We are already having a video on integers. So in this video we will be learning what is rational number, how to represent rational numbers on the number line, how to add, subtract, multiply and divide the rational numbers. All these things we will be learning in this video. So let's start with the rational number. So first of all, what is rational number? We have learned in the chapter integers that if we are going to have any two integers, say a and b are any two integers, and if we are going to add these two integers, if we are going to subtract these two integers, if we are going to multiply these two integers, then the sum, difference and product is always a integer. In each and every case, if we are going to take any two integers and we are going to add them, we are going to subtract them and we are going to multiply them, then in each and every case their sum, their difference and their product is also an integer. But if we are going to take two integers, then it is not compulsory. If we are going to divide these two integers, then the quotient will always be an integer. It is not compulsory. It may be the case or it may not be the case. Suppose I am going to take a as your 4 and b as 2. And if we are going to divide these two, we will be getting 2. That is an integer. But if the value of a is say 8 and value of b is say 5, then it is not the integer. The value of the quotient, whatsoever the quotient will be coming, it is not an integer. What the value will come? It will be your 8 upon 5, which is a fraction. And from here only the concept of rational number arises. So what is rational number? Any number which can be represented in the form of p upon q, where q is not equivalent to 0 and p and q are any integers. In that case, whatsoever the number we are getting is known as your rational number. So p upon q, any number which can be represented in the form of p upon q, where q is not equivalent to 0 and p and q could be any integer, such type of numbers are known as rational number. Suppose I am going to take an example. Say this is an example. Over here, value of p is your 8 and value of q is 5. So p and q, that is 8 and 5, both are your integers. So 8 upon 5 is a rational number. The number p is known as your numerator. P is known as numerator and q is known as your denominator. P is numerator and q is denominator. That simply means denominator should not be 0 and p and q could be any of the integer. Another example we can take, suppose it is your minus 3 upon 5. Here value of p is minus 3, value of q is 5, minus 3 is also an integer, 5 is also an integer and this 5 is not equivalent to 0. That's the reason we will be saying that minus 3 upon 5 is a rational number. So any number which can be represented in the form of p upon q, where denominator q should not be 0 and p and q could be any integer, such type of numbers are known as rational number. Now, what is the standard form of rational number? As we are saying that p upon q form is known as your rational number. Like if I am saying in the form p upon q, for the standard form, your q should not be equivalent to your negative number. Q should not be negative number. The denominator q should not be negative number and p and q should be your co-prime numbers. If these two conditions are fulfilled, then we will be saying that the given rational number is in its standard form. So any rational number will be in its standard form if denominator q will not be negative and your p and q both are co-prime. So what is the meaning of co-prime? That means they should not have any other common factor except 1. They should not be divisible by any other number except 1, or we can say the HCF and p and q should be on 1. If these two conditions are fulfilled, then we will be saying that the given number is in its standard form. Suppose I am going to take an example, say 7 upon 9. In the case of 7 upon 9, your denominator 9 is positive. Along with that, 7 and 9 does not have any other common factor except 1. They are not divisible by any other number except 1. So 7 upon 9 is a rational number and is in its standard form also. If I am going to take an example, say 3 upon minus 5. So 3 upon minus 5, it is a rational number, but here denominator is minus 5, which is negative. So it is not in its standard form. If we are going to write this as minus 3 upon 5, then we will be saying that this is in its standard form. And value of 3 upon minus 5 is equivalent to minus 3 upon 5. We can write this number as this also. So this is not in its standard form because denominator is negative, but this is in its standard form because denominator is positive, and both are having the same values. Similarly, if the number is say 6 upon 8, so 6 upon 8 is even a rational number, but again it is not in its standard form. Why? Because 6 is divisible by 2 and 8 is also divisible by 2. That means their HCF is not 1, HCF is 2. So if we are going to divide these 6 and 8 by 2, we will be getting 3 by 4. Now 3 upon 4 is a rational number and is in standard form also. So for the standard form of a rational number, the P and Q, P upon Q is a rational number and Q should not be negative and P and Q should be a co-prime. If these two conditions are fulfilled, we will be saying that the given rational number is in its standard form. Now, what is positive rational numbers and what is negative rational number? See, positive rational numbers we will be getting if P and Q, if the numerator and denominator both are having the same sign. If P and Q are having like signs or they will be having same sign. That means if both are positive or both are negative, in that case we will be saying that the given rational number is a positive rational number. Like if I am saying 3 upon 4, it is a rational number. 3 is positive and 4 is also positive. So it is a positive rational number. If the number is your minus 3 upon minus 4, then also it is a positive rational number. Because if we are going to divide any two negative integers, then their quotient is your positive only. If both are negative, so your numerator is even negative and your denominator is even negative, and if we are going to divide this, then your quotient will be positive. That's the reason if your numerator and denominator are either positive, both are positive or both are negative, so we will be saying that the given rational number is a positive rational number. Then what is negative rational number? If the sign of P and Q are having different sign or opposite sign. If they are having different sign or opposite sign, if the numerator is positive and the denominator is negative, or if numerator is negative and the denominator is positive, then such type of rational numbers are known as your negative rational number. Example could be minus 7 upon 8. Here numerator is negative and denominator is positive. So if we are going to divide it, the quotient will be negative only. This we have learned in the chapter integers, that if the two integers we are going to divide, they are having different sign, then the quotient is negative only. Along with that, if your example is say 7 upon minus 8, then also the quotient will be negative, because one is having the positive sign and the another is having the negative sign. Both are having different sign, they are having the opposite signs. That's the reason the quotient will be negative, and such type of rational numbers are known as your negative rational numbers. If we are going to see again that natural numbers, we have learned in the previous video that natural numbers are the numbers, counting numbers starting from 1. These are your natural numbers. Whole numbers are along with the natural numbers. If we are going to take 1 also, then this is your whole numbers. Integers are in the negative direction even up to infinity. That means these are the numbers which are your integers. All the natural numbers are whole numbers. Over here we can see all the natural numbers are whole numbers, but all the whole numbers are not natural numbers. Similarly, all the whole numbers are integers, but all the integers are not your whole number, because these negative numbers are part of integers, but they are not the part of your whole number. So we will be saying that all the whole numbers are integers, but all the integers are not your whole number. Similarly, we can say that all the natural number, all the whole numbers, and all the integers are your rational number. They all are your rational number. Rational number is denoted by your capital Q. Because of the word quotient, we are representing rational number by your capital Q. That simply means all the natural number, all the whole numbers, all the integers are rational number, but all the rational numbers are not your natural numbers, not whole numbers, and not your integers. How we can say that? Because suppose I am taking a natural number, say 3. So 3 could even be written as 3 upon 1. We can write 3 as 3 upon 1. So over here, value of P is your 3 and value of Q is your 1. P and Q both are integers and Q is not equivalent to 0. So 3 could be written as 3 upon 1 and 3 upon 1 is a rational number. Similarly, if I am going to take 0, so 0 could be written as 0 upon 1 also. 0 could be written as 0 upon 5 also. So again over here 0 is an integer and your denominator is not equivalent to 0. So 0 is also a rational number. Similarly, if we are going to take say minus 2. So minus 2 even could be written as minus 2 upon 1. So minus 2 is your numerator and 1 is the denominator. So minus 2 upon 1 is even a rational number. So we can say that all the natural number could be represented in the form of P upon Q. All the your whole numbers could be represented in the form of P upon Q. All the integers could even be represented in the form of P upon Q. And because they could be represented in the form of P upon Q, that's the reason they all are your rational number. But if I am going to say 7 upon say 3 upon 4. If I am taking 3 upon 4, so 3 upon 4 does not come under the category of natural numbers. It does not come under the category of whole numbers also, and it does not come under the category of your integers also. That's the reason we will be saying that all the rational numbers are not natural numbers, whole numbers, and your integers. Whenever we are talking about these numbers, which are towards the right of your 0, they all are your positive, and all those number which will be lying towards the right of 0, they will be positive rational numbers also, and the numbers which will be lying towards the left of 0, they will be your negative rational number, and 0 is neither positive nor negative. Now we will be learning how to represent these rational numbers on the number line. Now let's understand how to represent rational numbers on the number line. So we know how to make a number line. We will be making a straight line like this. At the center we will be taking 0. Towards the right of the 0 we will be taking the positive natural numbers, that is 1, 2, 3, 4, 5, 6 like this. The distance between these numbers will be equal, that is known as your unit distance. The distance between 0 and 1 will be equivalent to distance between 1 and 2, the distance between 2 and 3, the distance between 3 and 4. That means the distance between every consecutive number will be equal, and that is known as your unit distance. The same will be applicable towards left also. At the unit distance, I will be taking minus 1, minus 2, minus 3, minus 4, minus 5 and so on. So this is how we will be making a straight line representing all the integers. Now how to represent your rational numbers on this number line? Let's understand it. Suppose a number which we are talking about is your 3 upon 2. We have to represent say 3 upon 2, or we have to represent say minus 5 upon 2. These two are the numbers which we have to represent. Now how to represent it? So first of all, what we will be doing is we will be seeing that what is the denominator of the given rational number. Over here, the denominator of this rational number is 2. The denominator of this rational number is even 2. So what we will be doing is we will be dividing each unit distance into 2 equal parts. That means from 0 to 1 we will be dividing it into 2 equal parts. This is one part, this is another part. Again 1 to 2 we will be dividing it into 2 equal parts. Then 2 equal parts. Like this we will be dividing every unit distance into 2 equal parts. Why we have divided it into 2 equal parts? Because our denominator is 2 over here. Similarly, towards the left also we will be dividing every unit distance into 2 equal parts. Now each part is representing 1 upon 2. 0 to 1 is 1. So if half of this we are taking, then what it will be representing? It will be representing 1 by 2. That means distance between this point and this point. These 2 points is 1 upon 2. So this point is representing your 1 upon 2. This point which is representing 1 could even be written as 2 upon 2, because 2 upon 2 is 1 only. The next point is representing your 3 upon 2. Then 2 is representing your 4 upon 2, because 4 upon 2 could even be written as 2. Now we have to represent 3 upon 2. So 3 upon 2 is after 1 and before 2. That means the midpoint of 1 and 2 is representing your 3 upon 2. Suppose this point we are marking it as A. So point A is representing 3 upon 2. Similarly, we have to represent minus 5 upon 2. How we will be doing that? Now the distance between 0 and minus 1, this point, this midpoint is representing minus 1 upon 2. Minus 1 could even be written as minus 2 upon 2. The point between minus 1 and minus 2 is your minus 3 upon 2. The point minus 2 could be written as minus 4 upon 2, because minus 4 upon 2 is minus 2 itself. After that, it will be your minus 5 upon 2. That means point which is lying exactly in between minus 2 and minus 3. Suppose this point is your B. So point B is representing your minus 5 upon 2. Now, suppose instead of these, we have to represent, say, 5 upon 3 and say minus 4 upon 3. These two are the points which we have to represent. Then how we will be representing? First of all, we will be seeing that what is the denominator. Here, denominator is your 3. So, first of all, we will be making a straight line. In the center, we will be taking 0. Then at unit distance, we will be taking all the numbers 1, 2, 3, 4, 5 like this. Towards the left even, we will be taking minus 1, minus 2, minus 3, minus 4 like this. The distance between every consecutive number should be equal. That means it should be a unit distance always. Now we have to represent 5 upon 3 and minus 4 upon 3. Here denominator is 3. That's the reason we will be dividing every unit distance into 3 equal parts. Every unit distance will be divided into 3 equal parts. So 0 to 1 we are dividing into 3 equal parts. These are the 3 equal parts. 1 part, 2 part, 3 part. Then again 3 equal parts. Then again 3 equal parts, like this we will be dividing. And towards the left even, again we will be dividing every unit distance into 3 equal parts. Like this we will be dividing it. Now every small distance, this distance from this point 0 to this point is representing 1 upon 3. 0 to 1 is unit distance. So 1/3 of the unit distance will be 1 upon 3. So this distance is representing 1 upon 3. The second point will be your 2 upon 3. The third point, which is representing 1, could even be written as 3 upon 3, because 3 upon 3 is 1 only. The next point will be 4 upon 3. Next will be your 5 upon 3, and 2 could be written as your 6 upon 3. We have to represent 5 upon 3. So this point is your 5 upon 3, and this could be named as your, say, A. So point A is representing your 5 upon 3. Similarly, towards left, after 0, the first point will represent minus 1 upon 3. The next point will represent minus 2 upon 3. The next point, which is minus 1, could be written as minus 3 upon 3. Next point after minus 1 is minus 4 upon 3, and that is only to be represented. So we have marked it. Suppose the point is your B. So B point is representing your minus 4 upon 3. So what we need to do is, first of all, we need to check that what is the denominator. Whatsoever is the denominator, we will be dividing the unit distance into that much number of equal parts. And then every part, suppose your denominator is say 4. Suppose your denominator, this is your denominator, say your number is 7 upon 4. So here denominator is 4. So what we will be doing is, we will be dividing every unit distance into 4 equal parts. And every small part will be representing 1 upon 4. The second will be your 2 upon 4, then 3 upon 4. Then 1 will be representing your 4 upon 4, because 4 upon 4 could even be written as your 1. So this is how we are going to represent your rational numbers on the number line. Now let's see how to compare the rational numbers. Suppose we are having 2 or more than 2 rational numbers. Say we are having, these are the numbers. Suppose the number, one of the number is 5 upon 3. Another number we are taking as, say, 7 upon 3. Another number is minus 5 upon 3. Or it could be, the denominator could be different also. It could be your, say, 2 upon 4. If these type of numbers we are having, instead of 2 upon 4, because 2 upon 4 could even be written as 1 upon 2. So we can take it as 1 upon 2 also. If we are having so many numbers and we have to check which number is greater or which number is smaller. So how we can do that? If we are going to represent all these numbers on the number line, then whatsoever the number will be coming towards the right hand side will be greater than the number towards the left hand side. Suppose if this is one of the number, that is 5 upon 3, and we are comparing this number with 2 upon 3. So 2 upon 3 is towards the left of your 5 upon 3. That means 2 upon 3 will be smaller than your 5 upon 3. Similarly, we are going to check it with this number 3. So because 3 is towards the right of a point, that is your 5 upon 3. So we will be saying that this point 3 is greater than your 5 upon 3. So whichsoever number will be towards the right in the number line, that will be greater than the number which is towards the left. So all the negative numbers, because they are towards the left only, so all the negative numbers will always be smaller than any of the positive number, or they will be smaller than even 0. All the negative numbers will be smaller than 0, and all the positive numbers will be greater than 0. All the positive numbers will be greater than all your negative numbers also. Suppose we have to compare these numbers. This is one of the method. By checking on the number line, we can say that this number is greater or this number is smaller. Otherwise, what could another method could be? If your numbers are having the same denominators. If the number, these two are the numbers, we have to check which is greater or which is smaller. If your denominators are same, in that case, the number which is having the greater numerator will be greater. In 5 upon 3 and in 7 upon 3. Both are having 3 as the denominator. So 5 is smaller than 7. So we will be saying that 5 upon 3 is smaller than 7 upon 3. Or we can say 7 is greater than 5. So 7 upon 3 will be greater than your 5 upon 3. This could even be one of the method. Another method could be, what we can do is, suppose your number is 2 upon say 5. Another number is 3 upon say 7. This method is known as a cross multiplication method. So what we will be doing is, we will be multiplying 2 with 7, 2 multiplied by 7, and we will be multiplying 3 multiplied by 5. In cross we will be multiplying. 2 multiplied by 7 we will be doing, 3 multiplied by 5 we will be doing. 2 multiplied by 7 is your 14, 3 multiplied by 5 is your 15. 15 is greater than your 14, so 3 upon 7 will be greater than your 2 upon 5. Because value of 15 is greater than 14. So we will be saying that 3 upon 7 is greater than 2 upon 5. Similarly, if your another method could be, say we have to check 2 upon 5 and 3 upon 7 only. 2 upon 5 and 3 upon 7, we have to compare this. This is one of the method, which is your cross multiplication method. Another method could be, we can make the denominators equal by multiplying it and dividing it by a same number. So if we are going to multiply and divide 2 upon 5 by 7, and we are going to multiply 3 upon 7 by your 5. In that case, 7 2s are 14 upon 5 7 are 35. This is 3 5 is 15 over 5 7 is 35. Now the denominators are same. Denominators are same and numerator, this 15 is greater than 14. So this will be greater than your 14 upon 35, or we will be saying that 3 upon 7 is greater than your 2 upon 5. This could even be one of the method. So by any of the method, we can check that which number is greater or which number is smaller. And once we are knowing that which number is greater and which number is smaller, we can just convert it into ascending order. Even we can write it the numbers in the ascending order also, in the descending order also. Now let's understand how to find rational numbers between any given rational numbers. Suppose there are any two rational numbers given to us and we have to find say 2, 5 or say 3 rational numbers between these two rational numbers, then how we can find it out? So there are so many methods of finding rational numbers between any two given rational numbers, and there could be infinite of rational numbers between any two given rational numbers. So it is not compulsory that whatsoever the result is of your friends, the same will be of yours also. Both of you could be have different results and both could be your correct even. So how we can find any given number of rational numbers between any two given rational numbers? So first of all, what we could do is, over here we can see one of the denominator is 8, another denominator is your 6. So first of all, we can make the denominators equal. For that, what we will be doing is minus 5 upon 8. If we are going to multiply it by 6 in the numerator also and in the denominator also, the number will become 5 6 is 30, minus of 30 you're divided by 6 8 is your 48. Minus 30 divided by 48. Minus 5 upon 8 could even be written as minus 30 upon 48. Similarly, we are going to see minus 1 upon 6. Here denominator was 8. So if we are going to multiply and divide it by 8, the denominators will become equal. So it could even be written as minus of 8 divided by 6. 8 is your 48. Here we can see one of the number is minus 30 over 48. Another number is minus 8 upon 48. So numbers between these two rational numbers could be minus 9 upon 48, minus 10 upon 48, minus 11 upon 48, minus 12 upon 48. So many rational numbers we can write between these two rational numbers. Similarly, if we had multiplied these rational numbers, these two rational numbers by 10 also, 10 over here. So this could be written as minus 300 over 480, and this could be written as multiplying and dividing by 10, so minus 80 over 480. Again the denominators are same, 480 over here, 480 over here. So the numbers starting from minus 81 upon 480, minus 82 over 480, minus 83 over 480, up to minus 299 over 480. So many rational numbers we can find between any two given rational numbers. This is one of the method. Another method, if we have to find only one rational number between any two given rational numbers, then it could be we can add these two rational numbers and divide it by 2. We have to find the mean of it. That means we have to add these two rational numbers, minus 5 upon 8 plus minus 1 upon 6 divided by 2. Whatsoever the number will come, that will be the rational number which will be exactly in between these two rational numbers. If A and B are any two rational number, then rational number between these two rational numbers will be A plus B by 2. This will be the rational number which is going to lie exactly in between these two rational numbers. So this is how we can find the rational numbers between any two given rational numbers. We have to make the denominator same. Then from a smaller numerator to bigger numerator, you have to keep on moving, keeping the denominator same. Next is your addition of rational numbers. How to add the rational numbers? If we are having two or more than two rational numbers, how we can add them? So there are again two conditions are there. One condition is when the denominators are same and when the denominators are different. So when the denominators are same, what we will be doing is we will be keeping the same denominator and we will add the numerators. That is what is to be done. Now it is your 7 upon 5 and 2 upon 5. We need to add these two rational numbers. What we will be doing is we will be keeping the denominator same. So denominator will be 5 only and the numerators are 7 and 2. So we will be adding the numerators. 7 plus 2 will be your 9 upon 5 will be the answer. Now again the second case, here even the denominators are same. One of the denominator means both the denominators are your 9 only. So in the sum, the denominator will be your 9 only and we will be adding the numerators. Numerator over here is minus 4 and here it is your 2. And if we are going to add minus 4 and 2, what we will be getting is minus 2 over 9. So answer will be minus 2 over 9 when we will be adding these two rational numbers. So whensoever the denominators are same, in the sum we will be keeping the same denominator and we will be simply adding the numerators. Now the another condition is when the denominators are different. In that case what we will be doing is we will be finding the LCM or we will be converting them into equivalent rational numbers. That means here denominator is 5, here denominator is 7. We want that both of them should have the same denominator. So LCM of 5 and 7. 5 and 7 is your 35. So for converting this minus 2 upon 5 into 35, what we need to do is minus 2 upon 5 multiplied by 7 and divided by 7. Now the denominator will become 35. In the second case, plus 3 upon 7. Now we want this 7 to be converted into 35. For that, we will be multiplying and dividing by 5. So this part could be written as minus 2 multiplied by 7 will be minus of 14 divided by 5. 7 is your 35 plus 3 5 is 15 over 5 7 is your 35. Now we are having the same denominator, so same procedure we will be applying. In the sum we will be having the same denominator and we will be adding the numerators, minus 14 and plus 15. If we will be adding minus 14 and plus 15, the result will be 1 upon 35. 5. So this is how we can add the two given rational numbers. If the number of rational numbers are more, then also we can use the same method. If denominators are same, so we will be keeping the same denominator and simply we will be adding the numerators. And if denominators are different, in that case, first of all, we will convert it into the same denominators and then we will be adding the numerators. Now let's understand how to subtract the rational number. Again, we are having the same concept. One of the condition will be if the denominators are equal and another condition will be when the denominators are different. Now let's see how to solve it. If we have to subtract 2 upon 9 from 5 upon 9, that means this part is to be subtracted from this part. So this will be written as 5 upon 9 minus 2 upon 9 because this is to be subtracted from 5 upon 9. So 5 upon 9 minus 2 upon 9. Here denominators are equal. So we will be keeping the same denominators and we will subtract the numerators. So 5 minus 2 will be your 3 upon 9, or we can say it as 1 upon 3 also, because 3 and 9 both are divisible by 3. So the final answer will be your 1 upon 3. The next is minus 6 upon 11 is to be subtracted from minus 3 over minus 11. So how we will be writing it as minus 3 over minus 11 minus 6 over 11. This number is to be subtracted from this number. So we have taken minus sign for the subtraction. This was the number and this was the number. Now how we will be solving it? We know that if the numerator and denominator both are negative, then their quotient is your positive only. So 3 upon minus 3 over minus 11 could be written as 3 upon 11. When minus is multiplied by minus sign, 2 times minus sign is multiplied, then it is your positive sign. So this minus and this minus will turn to plus 6 upon 11. Denominator is same. So we will be taking the same denominator. Numerator positive sign is there in between. So 3 plus 6, that is 9 upon 11 will be the answer. In the next case, minus 6 upon 25 is to be subtracted from minus 8 upon 5. That simply means minus 8 upon 5 minus 6 over 25. So this could be written as minus 8 upon 5 minus will become plus. So we will be taking positive sign over here, 6 upon 25. Here denominators are different. So first of all, we will be converting it into same denominators. The LCM of 5 and 25 is 25 only. So we will be converting this into denominator as your 25. So this could be written as minus 8 upon 5 multiplied by 5 and divided by 5 plus 6 upon 25. Minus 8 multiplied by 5, 8 is 40, minus of 40 over 25 plus 6 over 25. Denominators are same, so we will be keeping the same denominator and minus 40 plus 6 will be the numerator. Minus 40 plus 6, one of the number is positive, another number is negative. So we will be subtracting these two, but bigger number is because negative, so final answer will be negative. So it will be minus of 34 divided by 25 will be the answer. We will be subtracting 40 and 6, it will be your 34, and because 40 is negative, so final answer will be minus of 34. The next question is we have to subtract minus 2 from minus 3 upon 10. So this could be written as minus 3 upon 10 minus of minus 2. This minus sign is for subtraction and this minus 2 is the number. That's why we have written it. Now this could be written as minus 3 upon 10 minus will become plus. 2 could be written as 2 upon 1 also. Now denominators are different. So we have to convert this 2 upon 1 into the denominator should be your 10. Now LCM of 1 and 10, we know it is your 10 only. So minus 3 over 10 plus 2 upon 1 multiplied by 10 divided by 10. For converting into denominator as 10, we have multiplied and divided it by 10. So the number will become minus 3 upon 10 plus 2 multiplied by 10 will be 20 over 10. LCM will be 10. Denominators are same, so we'll be keeping the same denominator and the numerators will be minus 3 plus 20. Again, one number is positive, one number is negative. So we will be subtracting the numbers, but the bigger number is because positive. So final answer will be positive. So it will be 17 over 10 will be the answer. This is how we will be subtracting the given numbers. First of all, we have to frame the equation. If this number is to be subtracted from this number, that means this number will come first, then minus sign, and then the another number. We will be writing like this. If the denominators are same, in that case we will be keeping the same denominator and we will be simply operating on the numerators. And if denominators are different, first of all we will convert it into the same denominators and then the same applications we will be doing it. Now let's see how to multiply the rational number. For the multiplication of rational numbers, what we do is we simply multiply the numerators and we simply multiply the denominators. Product of the numerators will be the numerator of the product and product of the denominators will be the denominator of the product. So what we will be doing is simply, if anything could be cancelled, we will be cancelling it. Here 5, 4 and 7, we cannot cancel it. Here 3 is even not cancelling. So what we will be doing is simply we will multiply the numerators. 5 multiplied by 3 will be 15 and 4 multiplied by 7 will be your 28. So 15 upon 28 will be the product of 5 upon 4 and 3 upon 7. Simply we have multiplied the numerators will be the numerator. Simply we have multiplied the denominators and it will be the denominator. In the second case, over here we can see that 3 and 6, we can cancel 3 and 6. One is in the numerator, one is in the denominator, so we can cancel it. 3, 2 times 6. So it will be minus 2 then. Now one number 2 upon 3 was your positive number and another number minus 6 upon 7 was your negative number. When we are multiplying one positive number and one negative number, the final product is always negative. Now 2 multiplied by 2, we have already taken the negative sign. So 2 multiplied by 2 will be your 4 and the denominator here it will be 1. 1 multiplied by 7 will be your 7. So product of these two numbers will be minus 4 upon 7. Similarly, if this is a number, here we can see that 9 and 27 both are divisible. 3 9 is 27, so it is 3, it is 1 here. 5 4 is 20, so it is 1 here, it is 4 here. Now see, this is, again I am writing it, this number is now minus 1 over 3. I have taken the negative sign in the numerator. We can do that. If the negative sign is either in the numerator or in the denominator, we can take it in the numerator. There is no issue. So this number could be written as minus 1 upon 3 multiplied by, again here it is your negative, so it is your minus 1 upon 4. We know if we are going to multiply two negative numbers, the final product will be your positive only. So product will be positive. So finally 1 multiplied by 1 will be 1 and 3 multiplied by 4 will be 12. So 1 upon 12 will be the product of the given numbers. So if anything could be cancelled in the numerator and denominator, we will be cancelling, and if it is not possible, then simply we will be multiplying the numerators and simply we will be multiplying the denominators. If there are more than two numbers, then also the same application will be done. Similarly, we will be multiplying all the numerators and we will be multiplying all the denominators. This is how we can find the product of any given rational numbers. Now let's understand what is multiplicative inverse. So we have already learned that the multiplicative inverse is basically the reciprocal of the number. It is simply your reciprocal. So how to find it out? Suppose your given number is say 3 upon 4. So what will be the multiplicative inverse of 3 upon 4? It will be your 4 upon 3. Suppose your given number is say minus 7 upon 8. So reciprocal of this number will be 8 upon minus 7, or we can say it as minus 8 upon 7 also, because if the sign, negative sign is in the denominator, though we can take it in the numerator also. So 8 upon minus 7 could even be written as minus 8 upon 7. So if the number is positive, then their multiplicative inverse will also be positive. If the number is negative, then the multiplicative inverse or the reciprocal will also be negative. Whenever we are dividing any two given rational number, so instead of division, we can multiply it by its reciprocal also, or we can say we can multiply it by the multiplicative inverse also. Both means the same. How? Let's understand. Suppose we have to divide any two given rational number. Suppose 15 upon 28, we have to divide this number by 3 upon 4. So this could be written as 15 upon 28 divided by 3 upon 4. Now what we will be doing is, instead of division, what we can do is we can multiply it by its multiplicative inverse. Whatsoever the multiplicative inverse of 3 upon 4. The multiplicative inverse of 3 upon 4 will be 4 upon 3. So instead of division, what we will be doing is 15 upon 28 multiplied by multiplicative inverse of your divisor, that is your 3 upon 4. It will be 4 upon 3. Now simply as we were doing the multiplication, we will be doing it. 4 5 is 24, 4 7s are 28, 3 5 is 15. So it will be 1 over here, 1 multiplied by 5 will be 5 and 1 multiplied by 7 will be 7. So if we are going to divide these two numbers, the quotient will be your 5 upon 7. Instead of division, we can multiply it by the multiplicative inverse of the divisor. Both means the same. Now, if we have to divide minus 20 over 9 by minus 5 upon 9. So, this could be written as minus 20 over 9 divided by minus 5 over 9. Now, what we will be doing is, instead of division, we will be taking the multiplication sign. So, minus 20 over 9 multiplied by. We will reciprocate it. We will take the multiplicative inverse of minus 5 upon 9. So, multiplicative inverse of minus 5 upon 9 will be minus 9 over 5. This will reciprocate, and the negative sign we can take in the numerator also. So 9 and 9 both are going to cancel. 5, 4 is 20. When we are going to multiply two negative numbers, final product will be positive only. So 4 multiplied by 1 will be your 4. In the denominator, both side it is 1 only. So it is 4 upon 1, or we can say that the quotient will be your 4. The next question is, if we want to divide minus 14 by 7 over minus 2. So how we will be writing is minus 14 over 1, even we can write it as divided by 7 over minus 2. So I am taking minus sign in the numerator. Instead of in the denominator, I am taking the minus sign in the numerator. Now division will change to multiplication. And this number divisor is going to reciprocate. So it will be minus 2 over 7. Again, both the numbers which we are multiplying are negative. So final product will be your positive only. 7 2s are 14. Minus 2 multiplied by minus 2, it will be positive 4. So this is how we can divide it. Instead of division, we can convert it into multiplication, and then we will take the multiplicative inverse of your divisor. Both means the same, dividing the number or multiplying by its multiplicative inverse. So this is all from this chapter. Hope it is clear to you that what are rational numbers, how to represent rational numbers on the number line, how to compare the rational numbers, how to add, subtract, multiply and divide the rational number. Soon we'll be coming with more videos related to class 7th maths curriculum. Till then, thank you.